I'll try and be quick. I've got about 30 slides, and just like the last gentleman was saying, I'm going to answer a bunch of questions about how, what, and why, and we'll just go ahead and start. So what's this talk about? This is a what question, right? It's about an open source project. This presentation, by the way, is online at this place. I'll have the link at the end, but it's on GitHub. And it was created for a AWS disaster response hackathon. It started on the 1st of December. I started it on the 12th of January. So I got in there late, had a SageMaker requirement, which is basically AWS's Colab, or Google would have a Colab. SageMaker is the AWS version. Jupyter Notebooks may be what you're familiar with. When that ended, I switched it over to the other concurrent one, which was the AWS Deep Learning Challenge. Sadly, the very first week when I started to set up the EC2 instance, I learned that this new deep learning instance from Havana Labs, which is an Intel company, that's the requirement. It doesn't support MXNet. So that happened. All right, so why do a hackathon? I've done 3 of them now. And I was doing this one because I was out of work and I was looking for work. And rather than look for work, really, I was like, I'm just going to do some work that's open source. And it was kind of fun, kept my mind busy. I'm still working on it, and I think it's beneficial. I think it's beneficial to mankind. I really wish I had better results. And then it's just got something of interest. I've done stuff in the past with machine learning, and I've done stuff in the past with image processing, and I wanted to blend the two. So it was just kind of something interesting to do. Looks like I can only use the mouse to scroll. So what does this project do? This picture, you're going to see that first. I took this picture and I was a little hesitant about posting it, but I think the guy was okay. This happened while I had webcams up of looking at bridges, which are provided by the NCDOT. And I was trying to detect icy bridges. To me, it had kind of a important personal feeling because I've experienced ice on the road here in North Carolina. I grew up in the mountains, and I've experienced it throughout my life. Like I said, does it work? No, but there's always next year, and that's what I'm hoping for. All right, so, well, why give a talk on something that doesn't work? Well, some stuff does work, right? I think the project is well documented and it's ready for contributors. So that's like you guys out there in TV land, you can contribute to this. There's a front end, which we're not going to talk a lot about here. If we run out of time, I'll demo it. The first MVP that I put out, and I'm trying to kind of do this like an agile development project where I'm not spending a lot of time doing analysis. I'm spending more time trying to get something working. The analysis tool is like the front end. I was looking at camera images, and I was trying to see like which are the best camera images to pick. And so that web app enabled me to do that. Also some things that work, like the recognition API for image label classification works. If you're unfamiliar with recognition, don't be worried about it. I was unfamiliar with it as well, but it's a microservice from Amazon that has the ability to do labels and custom labels classification. The problem with the out-of-the-box labels is it doesn't give bounding boxes. And so I'm trying to use it to say, okay, in this camera image, where is the bridge? It's like step 1, right? And we'll talk something about that. And in order to get those bounding boxes, you have to do a custom label identification. All right, and there's a back end, right? So like all the architecture to support using the REST API and using these different microservices. The content delivery network works, DNS works. The roles for the microservices are not like wide open. Image uploads work. There's an API gateway that enables you to use a REST API that works. There's a kill switch enabled, which is also open source in a separate project, which just says like, hey, if this thing gets, someone just starts hitting it and with malicious intent, can I shut the services down and cut it off? That's real important to me because I ran up like $200 one time just having something run. By the way, that Habana deep learning EC2 instance, that costs like $16 an hour. If it's running, that's a lot of money, right? So you don't want to get your services out of running away cost. Benefit to me is I am in the community builders and the user group leaders with AWS, and so AWS provides funding, so I didn't have to pay out of pocket. Some knowledge of MXNet is in place. I wish there was more of MXNet in it. And it's still not 100% secure. There is an error that I'm like, oh, okay, I knew I needed to work around this and provide a workaround. But, like I said, I got the kill switch there in case it gets out of control. I can shut that down. Sadly, but you don't improve unless you're failing, right? You got to learn from your mistakes. The first prototypes for the machine learning portion fail, and they were literally just intended to be like rough draft proof of concept prototypes. I didn't expect them to fail as bad as they did, and we'll talk about that. All right, so how is it built? Like I said, it's a microservice architecture hosted on AWS. The front end UI is Elastic Beanstalk. If you're unfamiliar with Elastic Beanstalk, maybe you know Google Cloud Platform and their services there, which are kind of like Cloud Function and Cloud, what I think it's called, Cloud Application. I can't remember now. So it used two pieces of that, right? You're going to use it's just a function to run, which is kind of the back end to the REST API. If you remember Eduardo, was his talk, he was talking about intersection over union. I've got that in place as a Lambda, which is just a function, right? You're passing up your parameters and is it union? That's all it is, right? There is some web scraping of the cameras using curl, bash, and cron, and that's simply because I didn't use an EC2 instance to do like the web scraping. My computer's always booted, it's always running, it runs Linux, just has a user level cron, and that cron does bash, and it uses curl to pull the images, which I pulled from the NCDOT. I'll talk a little bit more about the cameras in a second. There is some image processing via MXNet. The goal is to do a little MXNet for image processing, but later do more deep learning within an image concept with MXNet. Image labeling was done via SageMaker Ground Truth, and we'll kind of talk about that in depth. And the prototype image-based ML is via recognition, which, like I said, is like you can use it. It's pretty simple to use, and I think that it was designed for that practitioners could use it, not like a PhD in ML or anything to use it. So, a picture's worth 1,000 words, and we kind of hit on stuff, but you don't really see anything until you see something in a big picture. But on the left is like the user. On the right is the cameras. The cameras, like I said, were publicly accessible NCDOT, which is the North Carolina Department of Transportation cameras. The user can also look at the two MVPs. Like I said, the first one was really more just like a data analysis tool, which cameras are valid. The different icons here are for the different microservices as provided by AWS. Like you see the bucket, that's like, S3 buckets, right? You recognize that. There's like ground truth and the lambdas. I don't have API gateway in here, I don't think, unless maybe that's API gateway. I don't know. But so regarding the problem and the solution, or am I building a team, right? Which I kind of was doing both. So when I first started this, like I said, I saw the hackathon and I thought, oh, well, this is what I'll do. I'll use the icy bridges. I think that would, like I said, be beneficial. I also kind of thought, hey, I've got a little bit of familiarity with these webcams on WRL. I know they're out there. I've looked at them previously, and it says NCDOT cameras. And driving around the road, you see them, right? I had a few connections that I thought I could use, doing some of the work that I'd done, friends and neighbors. I thought I could ask them, and I could, get somebody to vouch for me to talk to the NCDOT. It didn't really work out as planned. And part of that was I was trying to get camera imagery. I knew from the very beginning that I wanted a high quality camera that was looking at a bridge and looking at it continuously so I could see it in time. And literally, I also asked them, do you have any previous data that you've captured, and I could just get the imagery and I don't have to go to a public webcam. And I learned that they don't save the imagery. However, when I was doing all this, talking to LinkedIn and speaking to friends, and I was writing emails, I had a canned email response to send to people. I even crafted it differently because I was trying to say, maybe coming in and telling them who I am to establish that I'm not just some hack or some hacker, trying to say, I've literally got an interest in this and these are my credentials. I made it a little different to kind of say, talking to them from an emotional point of view and trying to persuade them before I got into that, hey, can you provide me some information? However, I didn't get any responses really until I got on the NCDOT website, or this drivenc.gov website, where there was a form and you could solicit contacts back to them. And if you did that, I finally got in touch with somebody, and they put me in touch with somebody that I hope is actually attending today, who's a professional engineer, and a PhD on top of that. So if you know anything about professional engineering, I give a lot more credence to that than the PhD. That means that they've actually taken the tests and they've worked for people and they can sign government documents. And like I said, I found those contacts on the drivenc.gov website, which I was unaware of, and I'll show you. During the time that I was doing this work, I'm also doing daily recruitment efforts. I'm trying to get people involved. I'm chatting, I'm talking to people. And one of the things that I thought would be beneficial to me was, I like to be a continuous learner. I do stuff every weekend. I host 2 users groups, and I have workshops. I've taken gazillion classes. I think in certifications, I quit putting them on LinkedIn. I don't really think it doesn't really help me find a job, to be honest with you. But I think I have over 70 certifications post grad school. And I would see people saying I'm out of work, and I would say, well, hey, if you're out of work, come over here. And sometimes they would have negative posts, and I would be like, hey, come on over here and do some of this with me, and it'll give you something to do. It doesn't pay you, but it'll make you better. And oddly enough, it might make the world better. One thing that I've said this before, and I'll say it again, when I was working at a startup way back when, and I was first learning TensorFlow, I would go to guys that are supposed to be experts with TensorFlow, and I would say hey, look at this code. I've got this problem. And I remember one time one of the guys said, dude, you know it better than I do. And I kind of felt like I was, had garlic going to vampires. I've literally used that expression before, because I couldn't get them really to look at it. And so once again, I did a lot of that. Maybe I spent too much time trying to get people involved. Also, during this endeavor, I had people that would come in and they would say things like, I don't know how to do this. This is above my head. And I would say, there's a lot of tasks here, and you can help in any particular area of expertise, and I'm not driving you to do something. I'm just putting up kind of the framework, and you're kind of filling it in. And I remember I spent a lot of time talking to this one kid from India who was wanting to do HTML and the web page, and I was telling him I wanted to have time, I wanted to have that built, and I literally gave him the John F. Kennedy quote. You know what? We go to space not because it's easy, because it's hard. You got to grow and make, you know, things are hard. You got to attack them, right? And spent a lot of time emailing and trying to persuade him. I thought that he could do it. As you'll see the UI, it's not that complex, but I didn't get much response there. So with that said, let's go to the next slide. So what did I know before this thing was starting? Well, you know, I'd taken DSP in school. I'm an electrical engineer, undergrad, master's, and I was a PhD dropout in EE. I did get admitted, University of Maryland, Baltimore County. So I was familiar with 1D convolution. I really never did any 2D because I did all my stuff in audio. But I will say this, in 2015, this class here, Fundamentals of Digital Image and Video Processing, which was from the University of Washington, or that was from Northwest, I can't remember, the purple one. I took that class and it had like 2D convolution, and it was like really good. I really liked it. And I had taken a bunch of MATLAB classes around that same time frame, and so I kind of got familiar with it. But if you look, it's 2022 when I started this, and this has been a long time ago. So I had to come up to speed. And part of the reasons coming up to speed was I didn't want to let these skills get too cold. So I didn't really know a whole great deal. I knew some, and I was trying to I could happily explain it to people. One thing here of interest, when I was looking this up, this image and video processing from Mars to Hollywood with a stop at the hospital, that's from Duke University here in Durham. And once I worked at a startup, and one of the guys that was mentioned in one, he's not the official instructor. I worked with him at a startup. I tried reaching out to him as well on this. So some paid work in MATLAB, or I should have put that up there, in TensorFlow, but it was mostly in audio. The one thing with the MATLAB, though, I did have some satellite imagery. So like when Eduardo was doing his talk about using the satellite imagery and hyperspectral cameras, and I thought that was really interesting because I was like, hey, I could see a lot of stuff you're doing there. So what was unknown before starting? This was an AWS hackathon, and I had kind of started in 2020 a AWS users group, but I had mostly done stuff with like Deep Lens, which is like their, you can buy one of these devices. It uses recognition, but I really didn't get that far with it. I just like, you know, bringing it up, doing, I think we did one of the first canned labs, and then we started the second one, and you know, just other things came up. It costs money to run these things. They're also expensive. So I just didn't spend enough time in it, but I had a little bit of understanding of it, and that was where I heard of recognition, just really didn't use it a lot. I did say that on that previous class, I had taken around the time I was doing this, the AWS Gluon MXNet class. So I thought it was kind of interesting. You've got some concept of image processing built into the framework, and that guy that started it was also from Northwest Washington. I think he works at Apple now, and I can't remember his name, but I was like, well, if he started this from Carnegie Mellon, I thought it was interesting. Okay, so had a little for the front end. I just had the barest minimum experience with the web stuff, and that was like with one web app, and it was real quick to getting it in Google Cloud Platform because I had been doing GCP for a while, but it took me a while to get it working in AWS. I didn't have any knowledge of API Gateway, really. So I mean, so to me, this was like a learning experience. This is the drivenc.gov website that I found one time. I think I was trying to write one of the TV stations. I wrote both, and while I was trying to find their like for WRAL, I sent something to Digital Design Desk or something, and I didn't get a response. But I think it was at WTVD 11 when I was looking. I found a reference to this website, and basically, for the state of North Carolina, they've got like a map. You can zoom in and out on it. You can pick different items of interest, and you can get these cameras, and you can look at them, right? And from that, using Chrome developer tools, I could say, what is the URL? And then I could investigate it. So, once again, why the emphasis on the front end and an AI talk? I'm going to get to the AI in a second, but, in agile development, right? You got to get something up that works, even if it doesn't work that well, but hit the requirement and you can iterate on it. Plus, it was a hackathon requirement. The hackathon wanted to have what's your URL, and they wanted a video, but what's your URL for doing a demo? Also, like I said, not everyone has an interest in computer vision, but a lot more people know about the web front end. And I thought if I couldn't get somebody to do it, at least if I started it, it would drive some interest. And, in recruitment, you can need something shiny. You need something that they can hook into. But then again, I also had an interest. I wanted to know about how to do this on AWS and do it with a lightweight but high quality ability. I didn't want to put React in, for example. Along the way, I found this, and this is a link. It's down here at the bottom. It's also from this Washington area, right? And it was some guys. You can see the URL down at the bottom. I'm not going to pull it up, but it is two professors doing a paper website. I guess is a summary of their papers of looking at what makes a road icy. Some of it I thought was interesting was there's a temperature band. It's not just that it's ice, but it's in a certain band. If it gets too cold, it actually is not very slippery. Also, if it's a little warm, it's going to melt. And when it melts and it refreezes, particularly in the morning or in shade, it refreezes very smooth and becomes more slippery, right? Fog, you don't necessarily have to have precipitation coming down, just fog coming in and getting a cold and a dip in the road can cause ice on the road. All kind of things like that. However, I never got to the point of incorporating climate into this project yet. So, so with that said, this is a good kind of thing for a possible architecture that I was thinking, but it's not wholly implemented. Was it's going to, and I may have to do this now that I see some of the results that I've got, but take an image, pass that to a label detection DNN, right, or recognition. Part of prototyping with recognition is, my understanding is recognition, it's going to have a whole bunch of different types of ML models that are done to it, and it's going to kind of pick the best. I kind of think this is kind of like prototyping with GCP tables or their auto ML capability. But one of the things you'll see is not all these cameras are valid at any particular time. Right, you may have a camera, and I'll show you an image here in a bit, that might be turned offline, right? So if you were to go look at that camera, it's literally just text saying offline or something, not unavailable. Or it could have sun glare in it, or it could have ice or humidity on the lens. Or when I said ice on the lens, right? Or it could be a nighttime image. Like the cameras are always available. Trying to detect imagery at night might be difficult, and you might want to say, well, I just don't have enough info at this point in time. We're just going to filter it out, right? However, if you've got good visibility, maybe one of the things to do, because it does somewhat work to pick up a bridge with just the default classifier, and the default classifier works with just label detection, right? Not object detection, to say, is it a bridge or not? Like, if the camera is pointing at a road, there's no bridge to detect. I'm trying to subset the problem to make it simpler. With object detection, that was kind of what I was trying to focusing on at one point, and you'll see that I couldn't get good bounding boxes of the bridges. But when I was watching Eduardo, it kind of brought back what I had thought. Maybe I need to do like image segmentation to say let's highlight the bridges with segmentation, and then from that get a bounding box. There is going to be a little bit of image processing in terms of do we need to rotate, grayscale, edge detection, etc. And in this case, in this possible architecture, I'm putting it at this point, but it may actually be fitting into different places along the checkpoint, right? And then you could do classification. Does this image have ice, or do we have like a custom model that detects ice? And then you could throw in like the weather, right? And I think this step is important, because part of my problem was I was detecting the dotted white lines as patches of ice in a previous experiment. And then, getting back to the users on this side, you have like an indicator, ice or no ice, caution, or you're good to go kind of thing. So here is a camera as an example. This is a camera of one of the cameras that I kind of chose as a good candidate camera. Is my thing still showing, George? Okay.
Yeah, it's showing.
Okay, very good.
You're getting really close to your time. So.
Okay, we'll press. On this one of the things that regarding the cameras varied, right? I didn't, as I was looking at them, sometimes they're looking at the road, sometimes they're looking at the bridge, but this particular camera was looking at the bridge on 2 different occasions of where it snowed and where it was clear the day before. It's not the highest resolution picture, it's not the largest, but I thought it was pretty good. And feel for the guys driving in the snow, these big trucks. There was also another problem that the cameras were CORS protected, which is cross origin restricted sharing or something like that. And having to get that image from this public webcam and then being able to pull the bitmap out, there was a little bit of effort there. Like I said, I was not a JavaScript programmer. The cameras also had like a variable update period, variable view angle, variable quality, like I said. Because of the update period, I had a dupe removal problem of gathering my data. Not only that, the API changed like 3 times when I was doing it. So had that problem. But like I said, I finally made some contact with the NCDOT, and I think maybe in the future I might be able to get a steady camera. So I mentioned this previously, and all that, there's a image quality problem. So since I can't get camera images that are fixed, what do I do, right? Do I perform a detail analysis and write a paper and get analysis paralysis and study and yada, yada, yada? Well, I think that architecture about is the image good or bad could come into play. But before I start doing that, let's just try and test and see what happens. So approach 0 was, let's try to see if we can do a difference in edges. We're going to assume the camera angle's fixed and just determine a reference image and then perform edge detection. And it's literally like the other guy was talking about, mean absolute error. That's what we're going to do. Look at the pixel values and see how did they change. And here's an example of that. So of that particular camera that I just showed you, that Business 40 in Salem, here is a reference image for when it was a good day, and then a day that there was snow, right? If you do an edge detection, and this is the Sobel edge detection, so you'll get a little bit of artifacts, you'll get the edges, right? And there's just black. It's a grayscale picture. The more white it is, the more edge there is, right? Then when you do a difference of these two diagrams, it will come out like so. You just go through and start adding up all the pixel intensity values, take the average of them, you get a number, right? And you can take that number and you can qualify to say how far off you are from this. And I was particularly interested in this seam, the seam being, this is the edge between the elevated portion in the upper right and the roadway, which is non-elevated. You're probably going to have more ice up in this area, but it's also having a seam. You can visually see it. You've got an edge. I've got a demo there, but I don't have time to go through it. But if you were to click on it, it would kind of show you how this works. Approach one literally is, that's approach 0, right? This is even less sophisticated, but I thought it would work as well. And that is saying, locate the bridge bounding box, locate the seam bounding box, and perform an intersection over union, right? So if the bounding box encloses the seam, then you can assume that seam is visible and there's no ice, right? And, like I said, will optionally correspond with weather conditions. So here's a rotated image, and this is only because this is the only screenshot I had existing because I was trying to talk to people. The camera images, like I said, are not perfect for what you're trying to do. If you're trying to draw a bounding box, you can't draw trapezoids, right? You draw squares. So here is that seam. It's not perfectly, in there, but at least it's inside of a rectangular portion. The bridge is as well, and then you could crop it, right? And so that once it's cropped, that's what you would be looking at. I talked to a pal, and I hope Kent is here. I met Kent via LinkedIn. He suggested doing like a reflection coefficient, and I found a paper on it. It would require it's a little bit of stuff, but basically they're doing a histogram of pixel intensities. They also talk about doing wavelets and comparing them, yada, 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 but that's something that could be done. But if you can't find the bridge, you're kind of SOL, right? So as far as trying to locate the bridges, I labeled the images with SageMaker Ground Truth. I hadn't used it before. The nice thing about it is it's kind of a nice tool for labeling images. My problem with it is let's say you take 100 images. It looks to me like in order to create that data set, it's like one person has to do all 100 images. I don't have anybody labeling images for me, so it's not a problem, but I was hoping I might get like 4 people helping me label images, and so we'd only do 25 a piece, something to figure out. So back when I first started, I did this, and I was like, oh, this is the way to do it. I'm going to label all of the ice that's on a roadway, and I'm just going to give it all kinds of data. I'm going to give it pictures of roads, different camera images, bridges, you name it. However, not only does this take a long time to do, it was problematic. One is you've got way too many bounding boxes, so that when you go to train the image with like ground truth, before it even trains, it's looking at the data set and it says you've got too many bounding boxes. And so also these are kind of staggered and they overlap, because once again, this image is not rectangular. If you remember the other picture, I could do like along the roadway a rectangle that would say this is all of the ice portions. So
John, I think we need to stop here.
I
know we started a little late, but even with that, you're like almost 10 minutes over.
Oh, really?
Yeah. I didn't want to interrupt you because you were really on your thing, and it's great. I got a lot of positive comments as well. So people are really interested in what you're doing. I hope you guys are going to connect on Slack. Well, thanks, John.
Yeah, no problem.
This is super interesting. I also put a little translation about what NC dot and WRL was, so that everybody could know that. So
yeah. Well, just for the last thing, I don't know if I'm still sharing or not. These are the two. This is the web, the GitHub. This is like the MVP one, which has the different bridges and has stuff. And this is the MVP 2, which does have the predict. So, I don't know if I go to just as this is using the default label set. I would just show you something kind of really quick. Some sample imagery. Let's see if there's like, here's one that it's unavailable. If I were to do predict, he should come back and say, this is a business card, right? But if I go to something that's like a bridge, let's see what the predict on this is. He doesn't show a bridge, but he does get road, right? So he doesn't recognize that this is a bridge. And one of the reasons I was picking this guy was that it was showing like a white line that I could look for ice. One of the things that's kind of sad is if you look at some of these bigger pictures, like this one, this is a really nice big picture, but the one that I used was very small, which I think is this one, which does quite often look at a bridge, doesn't change as much, has some sun glare in the image. My problem was I was getting these little white lines as ice.
Artificial intelligence.
Data. Analytics.
User group.
AIDAUG.
Join AIDAUG today.